In the circle above, we've got a centre O, PR is the diameter of the circle, QS is drawn perpendicular to PR. In triangle OSQ, that's this one here, OQ is C, so in actual fact that's a radius, OS is A and SQ is B. We want to prove that the triangle PSQ is similar to triangle QSR. So let's focus in on what we're looking at here. So we're saying that this triangle here, PSQ, is similar to QSR, which is this triangle here. So I'm going to start by saying that angle PSQ is equal to 90 degrees, and that's simply because we have angles on a straight line. Let angle QPS be equal to theta, so that's this one here. That means that angle SRQ is equal to 90 minus theta. So this one here would be 90 minus theta. And there's two reasons there. Firstly, angle PQR is equal to 90 degrees, which is the angle in a semicircle, and then the angle sum of triangle PQR. So what we're saying, if that's 90 and that's theta, this one must be 90 minus theta. Now if we look at the top here, that means that this angle just here must be theta. So angle SQR is equal to theta, and that's the angle sum of triangle SQR, and therefore this angle just here has to be 90 minus theta. So angle SQP is 90 minus theta, and that's the angle sum. Actually, that's not the angle sum at all. Let's just get rid of that. That's because angle PQR is 90 degrees, as we stated before. And if this bit's theta, that must be 90 minus theta. And now if we look, we can see that the angles of this one are theta, 90, and 90 minus theta. For this one, it's theta, 90, 90 minus theta. So therefore, triangle PQS is similar to triangle QSR, and that's because the angles are the same. Now, let's look back at those two triangles again. So we know that's a right angle. We know that this angle here is the same as this angle here, and that this angle just here is the same as this one here. C is a radius, so this length is C, and that means that PS is equal to C plus A. And by a similar argument, SR is equal to C minus A. Now consider QS. In this triangle, QS goes between the blue marked angle and the right angle. So this side here corresponds to this side here in PQS. This side here, between the red marked angle and the right angle, has to correspond to this side in the larger triangle. So using proportions, for the larger triangle, we've got QS, and that corresponded to SR in the small triangle. That's got to be equal to PS in the larger triangle divided by QS in the smaller triangle. So QS squared is equal to PS times SR. Now QS is B, so B squared equals PS is C plus A, and SR is C minus A. So B squared is going to be C squared plus AC minus AC minus A squared, and so C squared is going to be A squared plus B squared.